at the stars, look how they shine for you. Everything you do, yeah, they were all yellow.
Let's go ahead and get started with video number 14. Before we go into explaining the topic of this video, which is scale factor, let's do a quick recap on what a dilation is. A dilation is a transformation that changes the size of a figure without changing the shape. As illustrated in the picture above, a dilation either reduces a figure or enlarges a figure. An example of a dilation would be your pupil. Your pupil dilates according to the amount of light that hits the eye. A dilation has a scale factor, which determines the size of the image. As mentioned previously, the scale factor is the number that determines the size of the image after a dilation has taken place. By definition, it is the ratio of lengths of the corresponding sides in the image and the pre-image. Let's go ahead and break the definition down. Ratio simply means fraction. A fraction or the fraction of the lengths of corresponding sides. Corresponding sides means matching sides. Let's take a look at the example. Let's go ahead and look at the example. My first image from left to right, I have triangle A, B, C. And this is the pre-image or the original. Also, for our purposes, we're going to put that in parentheses as the old. The image following to the right is triangle A prime, B prime, C prime. This is the result of the dilation. So this is my image, and in parentheses, the new. The scale factor is simply a number in the form of a fraction by which we multiply the side lengths from the pre-image to get the new side lengths after the dilation on the image. To find the scale factor, you simply set up a fraction, just like I have over here. Scale factor is equal to new over old, based on corresponding sides. So new goes on top as a numerator, and the old is your denominator. Let's go ahead and look at the example. So I have triangle ABC is the pre-image, and we went from the pre-image to the image, which again is the result of the dilation, triangle A prime, B prime, C prime. And as we can tell, the triangle got smaller. So this is a reduction. And over in the notes, it says if the image is a reduction, the scale factor is less than 1. To start solving for the scale factor, we're going to set up fractions according to corresponding sides. So we always start based on the rule we have scale factor is equal to new over old. So the new goes with the image, so that's the result again of the dilation. Let's go ahead and start with the side A prime, B prime. A prime, B prime corresponds to the side or matches the side AB on the larger triangle. So it's going to be A prime, B prime 4 over 8, which is the side AB. Let's go to my second side. I have B prime, C prime. B prime, C prime is 2 in length. So again, that's the new over the old, which is BC is a matching side, 4. So it's 2 over 4. The very last side, I have A prime, C prime. A prime, C prime is again the new. We always start with the new, the result of the dilation, which is 3 in length, and that matches the side AC, which is 6 in length. So that gives us 3 over 6. So all of my fractions reduce to this number, which is my scale factor, which in this case is 1 over 2 or a half. So my scale factor is 1/2. The answer for the scale factor can be in fraction form like we have here, 1/2. Or it can be in this format here with using this type of notation, which is read as 1 to 2. With the notation using the colon, just like in the fraction, new goes first. So new goes first, followed by old. So this is 1 to 2. Lastly, the scale factor is a number we multiply the side lengths by to get the side lengths for the image. So on our example, 8 times 1/2, 8 times 1/2 gives me 4. So those two sides correspond. These two sides correspond. I have 4 times 1/2 would give me 2. And the third side, I have this side corresponds to this side. 6 times 1/2 gives me 3. Okay, let's go ahead and move forward to the notes section of the GeoBook. Go ahead and open to the next available page and title it Scale Factor. Copy the question and copy the diagram. For question 1, we have that square A is a dilation of square B. What is the scale factor? Okay, to begin solving for the scale factor, first we're going to note that square A is the image, so this is the result of the dilation. And square B is the pre-image. This is my original or the old. So I have old and the new. So from old to new, this dilation is an enlargement. So the figure got bigger. From the notes, if a dilation is an enlargement, the scale factor is greater than 1. Since we are dealing with squares and all the sides of a square are equal, we only have to set up one ratio or one fraction to solve for the scale factor. So by the rule, I have that scale factor is equal to new over old. So my new, in this case, is on square A, that side length. So that goes first. That goes over in the numerator. I'm going to have 35 over the old. The old is from the pre-image, which is 28. So 35 over 28 is the scale factor. And I can reduce 35 over 28. So the number that divides evenly into both top and bottom number is 7. Okay, I'm going to go ahead and reduce the fraction. So I have 35 over 28. And 7 divides into both numbers evenly. So I'm going to have 5 over 4. Or we can also write it as 5 to 4 for the scale factor. Moving on to question 2, go ahead and copy the question and the diagram. For question 2, we have what is the scale factor of the dilation? Let's go ahead and start by identifying the pre-image and the image. The pre-image is here, and I know it is this rectangle because I just have the capital letters for the notation. And I know that this rectangle here is the image since I have the capital letters with the prime notation. So this one is the result of the dilation. So from here to here, we know that an enlargement happened. The figure got bigger. Let's go ahead and label the new and the old. So the pre-image is the old, and the image is the new. We need to find the lengths of corresponding sides in order to set up the fractions to solve for the scale factor. Okay, let's go ahead and take a look at the lengths of the rectangles. I'm going to start with the pre-image, which is the old, To get the length, I'm literally going to count the units across. I don't have to do the distance formula since it's a horizontal line. So I have 1, 2, 3 units. This side length is 3. For the new, the length would be, so let's go ahead and count the units again. 1, 2, 3, 4, 5, 6, 7, 8, 9. That side length is 9. We're going to do the same for the height of the rectangles. So we're counting the units across. And again, I could count the units across since it is a vertical line in this case. So I have 1, 2 units for the height. And on this side, I have 1, 2, 3, 4, 5, 6. To set up our fractions and find the scale factor, again, it is new over old. So let's look at the ratio or the fraction for the length of the rectangles. So we're going from new to old. From new to old, which is 9 over 3. I have 9 over 3, which reduces to 3. For the height of the rectangles, I'm going again from new to old. I have 6 over 2. 6 over 2 reduces to 3. So the scale factor is 3, or it can also be stated as 3 to 1. So again, the scale factor is a number by which the side lengths get multiplied by to get the side lengths of the image. So I have 3 times 3 gives me 9. 2 times 3 gives me 6. Go ahead and copy the question and the diagram. For question 3, we have determine the scale factor of the dilation of the triangles. And you're given the following information. You have that the side length for the side OA is 5, and the side length for OA prime is 10. So to set up your scale factor, again, it is the new over the old. So my new is the result of the dilation, which in that case is the side length OA prime, which is 10. So it's going to be 10 over the old, which is the original, the pre-image. So 10 over 5, and that fraction reduces to 2. So the scale factor in this case is 2, or it can be written as 2 to 1.
Cause you're a sky full of stars. I'm gonna give you my heart. Cause you're a sky full of stars. Cause you light up the park.